Alright, we go on to hypothesis testing. So it's similar to what we were doing in interval estimation. So the basics are the same, knowing when the population is known, when the population is unknown. Right, in real life we encounter situations which prompt us to make hypothetical situations or make tentative statements about variables. Hypothesis serves as a function of making tests to statistically prove or disprove these claims or hypothetical statements. Just like in confidence interval, in hypothesis testing we'll also look at the single mean and proportion, difference between two means and proportions. The same criteria used to decide when to use Z or T still applies, meaning it's unknown or known population standard deviation. Alright, when you're dealing with hypothesis testing, since we are dealing with a situation where you reject or do not reject null or alternative hypothesis, now to make your life easy, you must know that when you are formulating the null and alternative hypothesis, which is the first step of any hypothesis question, there will only be three different types. Only three. So whatever you're going to be doing with hypothesis testing, whether it's now or when you're doing chi-square testing, it doesn't matter. You're going to have a situation where, as you can see, on the alternative hypothesis side, there's always going to be the less than, greater than, less than, or not equal to sign. Nothing else. And then on the null hypothesis, there's going to be the less than or equal to, the greater than or equal to, or the equal to, in that arrangement. And it will always be these combined. It will always be these combined, and it will always be that. So you cannot have a situation where it's less than or equal to and like that. You can see it will be completely wrong. Similarly, you cannot have that and that. It will be completely wrong. So all your tests, when you formulate the null hypothesis, there will only be three forms. That makes your life much easier even to formulate. Alright, so any form of this type where there is a greater than or equal or less than sign, it means it's a one-tail test because you are only selecting one side, either the greater than or the less than side. But where there is equal and not equal to, you can see that you are taking either sides. So that becomes what is called a two-sided test. Alright. What's important now, let's go to our steps of hypothesis testing. So the first step is to state the hypothesis, which should be in the form as one of the three above. That's the first step always. The next is to find the significance level given. It will be told 0.05, significance level 1%, 5%, whatever the significance level. Now, just like in interval estimate, we need a critical value that is associated with that significance level. That critical value depends on whether it's a one-sided or a two-sided test. So I've summarized the table for you here, which makes your life easy because most of these hypothesis test questions will work with 10%, 5%, and 1%. Right. So for two-sided, the values will be similar to the ones of confidence interval. But for one-sided, there are the values. Those values for one-sided can either be negative or positive, depending on which one-sided test you are dealing with. Okay, these ones. It can be plus or minus. Plus or minus. So usually the plus are when you are dealing with a hypothesis test with an alternative hypothesis like this, and when you are dealing with an alternative hypothesis like this, it becomes negative. Okay, so this is an illustration of what we're talking about. For example, if you are testing at 5% and your hypothesis is in the form like that, so as you can see, our alternative hypothesis is less than, so your critical value will be negative. Your alternative hypothesis is positive, is greater than, so it will be positive, your critical value. So you have to just watch out for that, but it will become easy with practice. And then we go to the test statistic. Alright, test statistic is just like when we're doing interval estimation, the part of the margin of error, that's the part which we call the test statistic. So we're going to have different test statistics depending on what kind of hypothesis test we're doing, what form. So when you're dealing with a single mean, you're going to use either Z or T, of course, depending on whether the standard deviation is known or unknown. Mona, come, what's going on? And we can also use T distribution to check if it's, to find our test statistics, that is when the population standard deviation is unknown. Proportion, similar, we always use the Z distribution. Alright, now when you're dealing with the hypothesis test, we're going to have a situation where there is a difference between two means. So we talked about this, saying we can find out the sample of girls and boys. So those are two samples, the girls and the boys, so you can have a difference between the two means and the two proportions. Is he sleeping? You can come and listen to this lesson. Alright, so these are the formulas. We will deal with them and you get to understand how to use them as we work out questions. So when you're practicing, try not to put pressure by trying to memorize. Always go back to the formula until you are used to it. The more you practice, the more you get used to it, yeah? Alright. We'll go back to all of them. And we'll talk about what is a pooled variance case. And we'll also talk about what is a non-pooled variance case. So all of those are the formulas for test statistics. Step 4 will be to make the decision. So making the decision depends on which approach you have taken. So these steps are assuming we're using the critical value approach of hypothesis testing. There's also a p-value approach. So for now, we're only going to focus on the critical value approach. That's the one that is common in any question paper, unless it specifically said use the p-value approach. So you make a decision based on your critical value that you found. From there, the decision is either to reject or not reject. We never say we accept. And then the last step is to conclude your findings. So without wasting so much time, let's jump right into the questions, because that's the best way to ensure that you work out these things properly, because we can do this discussion over and over, but without practice it's so difficult to do anything. All right, we start with question 1. Alright, a manufacturer claims, okay, so I'll mark that, claims that the average life of the batteries produced by his firm is about 30 months. About Okay, this is the keyword there. You disagree, contending that the average life of the batteries is not equal to 30 months. A random sample of 100 batteries yielded a mean of 28.4 months with a standard deviation of 9 months. Perform a hypothesis test at 10% significance level. Alright, so as you can see, we do not know the population standard deviation. So this is a straightforward unknown standard deviation case. Unknown standard deviation. Remember, this is a typical population standard deviation unknown, because we don't know it. It's not given to us. We start. Step 1. HO H1, right? HO, we know it's a mean question. It's a question of mean because of average, so mean is represented by mu. The first one we know it's equal to, the other one is not equal to, and they said 30 months. Very simple and straightforward, right? And as long as we have equal and not equal to on our null and alternative, we know that we're going to, it's definitely a two-sided test because of this. Alright, so which means the next step is to do the decision rule. So we know that we are going to use t-distribution because our population standard deviation is known. Okay, so we know we're gonna need alpha equals to 10%, which is 0.1. But since it's a two-sided test, we're going to have alpha divided by 2, which is 0.05. If it's a t-distribution, since it's a t-distribution, degrees of freedom is equal to n minus 1. Our n is 100, minus 1 is 99. So we go to our t-distribution graph. I hope we'll find 99. We can't find 99. So we use the one written infinite here, and we want 0.05, so it will be this part, where 0.05 is here. Alright, there you go, 0.05 infinite, 1.64485. So we call it T crit. The crit will be at the bottom of the T. 1.64485. So if we have to draw, we'll come and just save our T distribution. So this is the acceptance This is the rejection. Reject. So we have negative 1.644, positive 1.644. all right, that's how it works. So we'll reject anywhere this side and accept anywhere in between. So that's simple. We'll move on to our third stage. Our third stage is the test statistic. So like we said, we go back, we look at our test statistic. This is just a one-sided test for a single mean, so it's definitely this one. As you can see, the one that doesn't involve. So t-calc, we call it a t-calc, equals to x bar minus mean over standard deviation divided by root n. Alright, they said the sample yielded a sample mean, so this one is the x bar, this is the n, this is the s. So simple. Alright, x bar is 28.4 minus 30 divided by 9 divided by root 100. Alright, so we use our calculator, we don't need to waste time. There, 28.4 minus 30 divided by 9 divided by root n, root 100. Alright, straightforward. Negative 1.78. So as you can see, step 4, we compare where our critical value and our chi-squared calc. On our decision rule, we can either represent with a diagram like this alone, or we can add to say, okay, reject H or if. So we know we're going to reject if it's somewhere in this side or somewhere in this side. Alright, so if our t-calc is going to be less than negative 1.644 or t-calc is greater than 1.644, that's where we will reject. So in our case, our t-calc that we got, which is this one, we know it's less than negative 1.644, right? So therefore t-calc negative 1.78 is less than t-critical, which is negative 1.644. Therefore we reject H naught. We reject, it lies in the rejection region. The negative 1.7, it's somewhere here. That's where it lies. Then conclusion. So if we reject, it means we are agreeing with the alternative. Therefore, the mean, the average life of the batteries is not equal to 30 months. At 10% significance level, the average battery life is not equal to 30 months. Very easy. Recap. State your null and alternative hypothesis, which is here. Based on the question, they said equal or not equal. Second step, find the critical value. Since it's an unknown standard deviation case, we're going to use the t distribution. With n minus 1 degrees of freedom, our n is 100, minus 1 is 99. We can't find 99 at the table, so we take the infinite because it ends up to 30. From there it's infinite. So anything from 31, 32, you can always get just the infinite number. Right, what is important is the alpha. So in this case it was alpha over 2, meaning you had to divide our alpha, which is 0.1 divided by 2, we ended with 0.05. So you look at 0.05. From there we state our decision rule. This is how you state your decision rule, to say reject H or if, depending on what the graph is saying. So the graph is, you can have the graph or you can just state the rejection rule this way. From there you go to your t-calc, which is the formula of the test statistic. You always go back to the formulas and see which one to use until you are used to how they work. Based on the test statistic, you compare with your graph or your rejection rule and decide whether you do not reject or whether you reject, and then you make a conclusion. Simple. Let's look at number 2. The management of Windhoek Youth Club claims that its members lose an average of £10 or more within the first month after joining the club. A consumer agency that wanted to check this claim took a random sample of 36 members of this health club and found that they lost an average of £9.2 within the first month of membership. The population standard deviation is known to be 2.4. So you can see here we are given our known. So this is known. So definitely we're going to use our Z distribution, and we start. Test the management's claim at alpha equals 0.05. State the null and alternative hypothesis. So the first part, null and alternative hypothesis. So we know HO, H1, mu. Alright, they said it claims that its members lose an average of £10 or more within the first month. £10 or more. Okay, that's the claim. A consumer agent wanted to check if this claim is true. Okay, so mean, remember here in this case, our mean means average pounds that are lost. Average pounds that are lost. So we know average pounds that are lost, meaning mean, our average pounds that are lost are greater or equal to 10, because that's the claim. Greater or equal to 10. Greater or equal to 10. So obviously the alternative is less than 10. So is that okay? Alright, should be okay. From there, what is a single or two-sided test? A single-sided test, it's one that is only looking at one side of your claim. Two-sided is the one that is equal or not equal. Number 2, we state the rejection rule or the decision rule. So since our standard deviation is known, alpha equals 0.05, and it's a one-sided test. We don't divide our alpha, so alpha equals 0.05. we know already, and it's a z test. Z test. We come and look at our table. Z test 0.05, so it's this one, 1.645. What determines whether it's positive or negative is the less than sign here. So it's going to be negative 1.645, our critical value. So we can come and draw negative 1.645. So we know that this will be acceptance. This side will be rejection. Alright, we summarize it. Reject HO if Z calc is less than negative 1.645. Alright, we go to step 3. Determine, we find the test statistic. So we know Z calc equals to x bar minus mean over standard deviation over root n. X bar 9.2 pounds from that measurement, 9.2 minus 10 divided by 2.4 over root 36. Population standard deviation is this one. This one is the x bar. This one is the n. Straightforward. Come and put in our calculator. 9.2 minus 10 divided by standard deviation over root n. So it's negative 2. 4, we compare our Z calc. Since Z calc, which is negative 2, is less than Z critical, which is negative 1.645, we reject HO. So our Z calc lies somewhere here, negative 2. You can see on the graph, it lies within the rejection area. So 5 will conclude. So if we reject HO, we are saying, therefore, the average lost, members lose, it will be less than 10 pounds. The average weight loss at 5% significance level, the average weight lost is less than 10 pounds. So which means the Jim's claim is not correct. Done. Very simple. One-sided test with a non-standard deviation. So we call it The first question, we call it unknown. So you can see the only difference is the known and the unknown, it was just one we use T distribution and the other one we use Z distribution, and one is a two-sided and one is a single-sided. Very easy to identify. So for now we end there, and I send the question, the video before it becomes too big. Yeah, and then we continue on the next video. So this is part 1 of our hypothesis testing.